Okay, welcome back to the topics on linear and quadratic functions given the worded problem. Okay, so let us have some more examples about these functions. So I have here a problem about a class reunion in which everyone there shakes hands with each other as a gesture of greeting. Okay, and then there would be a follow-up question asking about how many handshakes will there be if there are 64 attendees, how many attendees will there be if there are 3,160 handshakes. Okay? So we could be assisted by constructing a table of values for this problem, okay, similar to what we have solved or similar to what we have done last time. Okay, so again, the problem is about there's a class reunion and everyone shakes hands with each other as a gesture of greeting. So if there will be 64 attendees or 64 persons in the class reunion, so how many handshakes will there be? And then the other problem is if there are 3,160 handshakes, so how many persons were there? Okay. So by constructing a table of values, so we have to set first the notation for the variables here. Okay, so let n be the number of persons or attendees, and then let us have our notation to be h of n for the number of handshakes. There. With respect to the construction of values, so let us start with n to be 0. Then, of course, the number of handshakes, if there are no person present in the reunion, there will be 0 handshake. And if there is one person, of course, that person cannot shake hand or handshake with himself or with herself, so that would also be 0. And then if there are two persons, there will only be one handshake. And we can represent that using this illustration. If there are two persons, let's say person A, person B, so that means there is one handshake. Now, if there are three persons, so how many handshakes will there be? So three persons, let's say person A, person B, person C. So person A with person B, person A with person C, and then person B with person C. So there will be 3 handshakes. Now, if there are 4 persons, let's say person A, B, C, D. So this is person A, person B, person C, person D. So A to B, A to C, A to D, B to C, B to D, and then C to D. So how many handshakes? 1, 2, 3, 4, 5, 6 handshakes. Okay? So from the question, how about if there are 64 attendees? So how many handshakes will there be? That. Okay. So to answer this question here, so a method that I have already introduced to you before was to find a pattern or a model for this problem. Okay, can I put this aside now, the illustration? So what should we do before finding the pattern? So we have to get first the first differences of the dependent variable or the independent variable. So that's 4 minus 3 is 1, 3 minus 2 is 1, 2 minus 1 is 1, 1 minus 0 is 1. So since all the differences for the independent variable are the same, so we can now proceed to the dependent variables. 6 minus 3 is 3, 3 minus 1 is 2, 1 minus 0 is 1, 0 minus 0 of course is 0. So the first differences are not similar, so therefore this is not a linear function. As we have defined before, this table, the table of values will be of the linear function if the first differences of the dependent variable are the same. So let's proceed to the second differences. That's 3 minus 2, 1. 2 minus 1, 1. 1 minus 0 is 1. So therefore, second differences are the same. So that is a quadratic function. So the problem of handshaking is about quadratic function. And we also have learned that for a quadratic function, we should be guided with y is equal to ax squared plus bx plus c. But for the sake of this problem, the y is the number of handshakes is equal to a, the x is the number of attendees or persons in the reunion, so that's b sub n plus c. So to proceed, we need to find the constants a, b, and c. Okay, so have a quick glance of this page because I'll be putting this aside. Okay, so from this table of values here, to find the values for the a, b, and c, let me use for, okay, let me rewrite the table of values down here. Okay, so n, h of n, so 0, 0, 1, 0, 2, 1, 3, 3, 4, 6. So a while back, we have already investigated that this table of values is of quadratic function. Okay, because the second differences for this row of numbers are the same. Okay, so let me use the 0, 0. So by this time, I'll be getting the values for a, b, and c. So let's 0, 0. So this 0 here is the n. The 0 here is the h of n. So therefore, this will be 0 equals a, x is 0 squared, plus b, your x is 0, or your n, plus c. So of course, that will give us 0. So c is equal to 0. So we now have the c. Next point, 1, 0. So for this point, this is 0 equals a, your x is 1 squared, plus b, your x is 1 or the n is 1, plus c, which is 0. So we now have 0 is equal to 1 squared is 1 times a, that's a, 1 times b, that's b. So having this equation alone, we can solve for a because we do not have the value for b. In the same case as solving for b, we do not have the value for a. So let me use another point, which is 2, 1. Anyway, you may use 3, 3, 4, 6, but for me, I'll be using 2, 1. You may experiment using the 3, 3 and the 4, 6. Anyway, we get the same answers. Okay, let's have 2, 1. So this will give us 1 is equal to a. Your n or the x is the 2, then square plus b, that's 2, plus c, which is again 0. So this will give us y equals 2 squared is 4 times a, that's 4a, plus 2b. So we now have these two equations here that will help us to get the values for a and the b. And it is a requirement, or it is being asked from the problem that we will be using substitution method. Okay, let me put this here and this page here. So by substitution, so as the problem is requiring for the substitution method to solve this problem, to solve this. Now let us use here by substitution. So by substitution. Okay. So from this equation, 0 is equal to a plus b then I could have my A be equal to negative B by transposing the B to the other side, and it will be like this. And this A here is the same as the value of the A here. So by substitution method, so we could have 1 equals 4, wherein your A is negative B plus 2B. So I have now 1 is equal to negative 4B plus 2B. So this will give us negative 4B plus 2B, of course, that's negative 2B. Divide both sides by negative 2. So we now have a value for B which is negative 1/2. So we now have the B as negative 1/2, C as 0. Then it's time for us to find the value for A. Then let's go back here. A is equal to negative B. So by having this, so since A is equal to negative B, so we have already the value for B, which is negative 1/2. So by substitution again, so finally we can have A as positive 1/2. Because it's negative 1 times negative 1/2 is positive 1/2. So finally, we already have the constants for A, B, and C. So going back here, this one. So going back here, we can now have the pattern. Okay, so let me write again the values that we have found. For A, we have it 1/2. For B, negative 1/2. And then for C, which is 0. So having this guide here, so it will now be h of n equals your A is 1/2. So that's n squared plus B, which is negative 1/2. N plus your C, which is 0. So finally, the pattern for the problem is h of n is equal to 1/2 n squared minus 1/2 n. So this now will help us to find the questions that we have to answer regarding this problem. If you still remember, the question was about the number of handshakes if there are 64 attendees, and then the number of attendees if there are 3,160 handshakes. Okay, so let me put that here and this one here. So again, what if there are 64 attendees or persons in the reunion? So how many handshakes will there be? Okay, so again, going back to this table, if there's no person, no handshake. 1 person, no handshake. 2 persons, 1 handshake. 3 persons, 3 handshake. 4 persons, 6 handshake, and so on and so forth. Actually, you can do this manually, but the point is you do not have all the time in the world, so we have to use this pattern so that it would be easier for us to solve the problem. So if n is equal to 64, having this pattern now, or using the pattern, so that is h. If n is 64, then we will be having 1/2. N is 64, then we're going to square that, minus 1/2, then the n is 64. Okay, so by solving further, so the 64 squared will give us 4,096. So that's 1/2, 4,096 minus the 1/2 of 64 is 32. So what is 1/2 of 4,096? So that is 2,048. So minus 32. So therefore, if there are 64 attendees or persons in the reunion, then we will be having 2,016 handshakes. Okay? There you go. So have a quick glance again of the solution if n is 64, because we will go to the next problem, in which it is asking about the number of persons in the reunion if there will be 3,160 handshakes. So by this time, the h of n is given. So the n is what we're going to solve. So there you go. So if the h of n is equal to 3,160, so that means 3,160 handshakes. So how many attendees or persons will there be? So again, using this model here, your h of n is 3,160. That is equal to 1/2 n squared minus 1/2 n. Okay, you have to carefully watch what I'll be doing with this, because this is kind of complicated for you, okay, to do this, because we are looking for the number of persons, and we have noticed that our n here is squared and the other one n here is raised to 1. So if you will be recalling your previous years of having mathematics, then this will tell you that this is a quadratic equation. And quadratic equation again, okay, quadratic equation, okay, for quadratic equation, there are many ways to solve this, okay. So this can be solved using factoring, this can be solved using completing the square, okay, completing the square, and then this can be also solved using, I think, extracting the root. Yeah, you also have this method, and then most of the students are asking for the formula, so that's why we can also use the quadratic formula. So I hope you still memorize this formula. Okay, so these are the 4 methods. You may choose any, whichever is more applicable or the most applicable to solve for the quadratic equation, because in this case we will be having a quadratic equation. So what I'll be doing is, to simplify this equation, I'll be multiplying it to 2, because that's 1/2 and 1/2. So 3,160 times 2, that's 6,320. Then we will be having 1/2 n squared times 2, that will give us n squared, minus 1/2 n, that will give us n. Then if you're going to transpose this to make it a quadratic equation be equated to 0, then it will give us n squared minus n minus 6,320 equals 0. There you go. If you're going to use the quadratic formula, you should identify your a, b, and c here. It's not the same the a, b, c that we just have solved a while back for the pattern of the problem. So the a here is 1, the b here is -1, the c here is negative 6,320. So what I'll be doing is, in this case, I'll be using quadratic, not the quadratic formula. I'll be using factoring. Okay, so try to recall your factoring, because I will not be discussing it here. So if by factoring, okay, so by factoring, so this will be n squared minus n minus 6,320 equals 0. Of course, in terms of factoring, you have to concentrate on the last term, which is negative 6,320. Find factors for this. If you multiply, you will get negative 6,320. But if you add those two factors, you will get -1. So for this case, it will be negative 80 and positive 79. So by this case, negative 80 times positive 79 is negative 6,320. And negative 80 plus positive 79 will give you -1. So therefore, the factors are n minus 80 n plus 79 equals 0. And then to find the n, let's divide these factors into 2. So you have there n minus 80 equals 0, and n plus 79 equals 0 also. So transpose negative 80 there, 79 there, so then we will have n is equal to 80, then n is equal to negative 79. Since from the problem we are being asked to find the number of attendees, to have 3,160 handshakes. Where is it? 3,160 handshakes. If h of n there is 3,160, so how many attendees? So you cannot have negative 79 attendees, but because that's negative. So therefore we have to discard n is equal to negative 79, and we are going to have 80. So therefore, to have 3,160 handshakes, there should be 80 attendees. Okay? So did you get it? I hope you got everything here. Okay, so these are now the solutions for this problem about handshakes. In the next video, we will be going to have another problem